So I've added another whiteboard, and if you need the rules that we've come up with so far, you can review the other videos. Hopefully you've taken some notes on them. But what we're going to do right now is cover a new type of power, one we have not seen. And like with the negative power, it's something you're just going to have to trust me with. So let's get started. Let's say we have this, x raised to the half, or 4 raised to the half, or a raised to the half. Before all of our variables or numbers were just regular numbers raised to whole number powers. And we also have the negative one. In this instance, when you have something raised to a power like that, you have to take special consideration. So let me clear this off so we can start to look at them. And for some reason, some of these lines don't erase, but that's okay. So let's look at a raised to the 1 over the m. This is just something you're going to have to remember. This is equal to the mth root of a. And you're probably saying, what? Well, let's make it even more interesting. Let's say I've got a to the m over n. That's going to be a to the nth root of, the nth root of a to the m. And I probably should make this to be a little bit more consistent, and so it's not confusing. We're going to turn these both into n's, since that will make it a little bit easier to understand. So we'll make u an n, and we'll make u an n. That way it's a little bit more consistent. So 1 over n, if you raise a to that power, then you're going to get the nth root of a. If you have a to the m over n, you're going to get the nth root of a to the m. So let's throw some numbers in here. So let's look at our handy dandy 2 raised to the 3 halves. This will be the second root, or the square root of 2 to the 3rd power. And just for clarification, the square root, we don't usually write anything here, but that's actually equal to the second root. There we go. So what does this mean? Well, the square root of something is how many times a number, it's not how many times, it is the value of a number multiplied by itself, what we would get if we reverse that process. So the square root of 4 is the same thing as the square root of 2, or just 2. And this only works with perfect squares. So our perfect squares are 1, 4, 9, 16, 25, 36. And that's 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, and 6 times 6. So the square root is reversing the process. All right? So if I take the square root of 4, I end up with 2. But let's look at something cool. We know from up here that the square root of 4 is the same as 4 to the 1/2. We also know that 4 is the same as 2 squared. an ugly looking 2. So I'll make it a little bit better. We know from our previous exercise, raising a power to a power is the same as multiplying. So we end up with 2 times, to the second power times the 1/2 power, and that's just 2 to the 1, which we know is equal to 2. So this is just something that you're going to have to know. And you're going to have to be able to use that knowledge. So in review, a to the mn is the nth root of a to the m. And a to the 1 over n is equal to the nth root of a. So it's something that you're just going to have to know. The key here is being able to go from one form to another, just like we did here,